Wow. Mantap juga ni.
Okay, mantap. Okay, aku mula.
Okay guys.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. We from group 17. Today we're going to present about our group assignment project. It is clamper circuit with non-sinusoidal input. Okay. Now, firstly, I will proceed to the manual calculation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aidul Zaid. My matric number is CE190070. So today our group would like to present our manual calculation based on our circuit. So this is our circuit, and this is our input voltage for our circuit. So in a clamper circuit, a vertical shift at upward or downward take places in the output waveform with respect the input signal. So the load resistor and the capacitor affect the waveform. So the discharging time of the capacitor should be large enough. So we are using or finding the current in time domain. So based on this circuit, we can get the Z in by using this formula. Y1 equal to 1 over R1, R which is resistance plus J omega C. C is for capacitance. So after we put the value, we get the final answer is 1.4, 2.4 I multiply 10 the power of negative 9 plus J1. It is equivalent to 2 plus J1. So in power form, we get the square root 5 in degree of 36.556. So after we get the Z in, we can put it in this formula. I time domain. So V1 time domain over Z in. So the Fourier series of input voltage are contain of circuit, system interpretation, output coefficient, and the last one, multiple component signal. So for Vs, we can get by using this formula. 4 multiplied by V2 over N multiply square sin omega t. So for the V2, we put the value is 20. So after we calculate, we get the answer is 18 over N multiplied by sin omega t. So for the N, we assume it is 1. So we get the final answer for IS is equal to 18 over square root 5 multiplied 26.06 in the bracket and multiplied by sin omega t. So we get the value of Vs and the Is. So let's proceed to the power input. So the power input, we use this formula. VRMS multiply IRMS multiply cos theta. So V1 RMS is the fundamental voltage, while IRMS is fundamental current, and the last one is cos theta for the fundamental input power Fourier. So by using this formula, we put the value for each of them. For VRMS is 18 over square root 2 pi. For RMS is 18 over square root 2 pi multiply square root 5 pi in degree of negative 36.56. And for the cos theta is 0.8944. So after we calculated, we get the value of active power decline is 129.0x6871 watts. So after all this calculation, we can know the input filter is drain of energy and then the grid recovers. So next, I would like to pass my presentation to my teammates.
Okay, my name is Muhammad Nushafiq bin Aizal. Matric number CE190172. Okay, for the simulation and result, firstly I want to explain a bit about our circuit. This is our circuit, clamper circuit with non-sinusoidal input. As you can see in our circuit, consists of RLC component. The value of R we use is 2 ohm, the value of capacitor we use 1 nano, and the value of inductor we use is 1 Henry. Okay, for the simulation setting, as you can see in diagram 2, for the runtime, we put 10 second. And for the step size, we put 0.001 second. Okay, now I proceed to the result simulation for voltage. Okay, as you can see on the diagram 3, there I have two probe. The green probe is placed to V1 is to measure the input voltage, and the blue probe is to measure the output voltage. Okay, for the result of voltage, as you can see for the waveform, the green color waveform is for the input voltage, the blue color waveform is for the output voltage. Okay, for diagram 5 is the result for in form of fast Fourier transform for voltage. Okay, for now I proceed the simulation result for current to my teammate.
Hello, Assalamualaikum. My name is Nabil Fikri. Matric number 60203. So, swimming sector result for current. This is this is the circuit that we made at the magnet, and we put the value for inductor, capacitor, and resistor. So the current one is red color, for blue is current 2, and green is current 3. So the result is the upper one that the color green is for current 1, the blue, the middle is current 2, and the red is current 3. So the first power transform circuit for this circuit is like this for graph. So for the power, circuit is like this. So the result for the power is so like this. The waveform for power in diagram 3.10, and the first Fourier transform so like this. So I pass to my teammate for continue to conclusion.
Okay, so as a conclusion, in this project, we are able to finish our task, which is to calculate, simulate, and develop a complete electrical network consists of resistance, capacitance, and inductance, which is RLC, for any mesh model with time for Fourier series calculations. So, uh, we know that the four series is useful in many applications ranging from experimental instrument to rigorous mathematical analysis techniques. The Fourier series offer us a precondition for creating a stable basis to consider the interaction between the time domain frequency and communication signals. It is ideal for voicing non-sinusoidal periodic function in an essential and harmonic function that can represent a discontinuity function. So that's all from my team. Thank you and assalamualaikum.